Hello everyone, welcome back to MAT052. In this little section, we're going to cover a little bit of just notation inequalities in continuous when we're dealing with continuous distributions. So we kind of did a version of this when we talked about discrete random variables, x greater than 3, x less than or equal to a number. But this is continuous distributions. There's a little bit of difference in the notation that I'd like to go over with you. Okay, so let me get this thing going down over here. So continuous versus discrete. So we started dealing with continuous in chapter 6. Suppose that an airline states that passengers may check no more than 2 bags and that each bag must weigh no more than 40 pounds. Now suppose that a passenger is selected at random, and we define x to be the number of bags that the passenger checks and y to be the weight of the heaviest bag. Both x and y are random variables as far as statistics goes, but there's a difference between the two types of measurements, as you probably rationed out. The possible values of y are any real numbers from 0 to 40. So it's not just 1, 2, 3, 4, up to 40 pounds. It could be 30.9 pounds, 30.95 pounds, 15.2. So we have to take into account when we're dealing with continuous numbers, continuous random variables, that it could be anywhere in a large range. Okay, so here is, let me get this thing started. So the possible values of y are any real numbers from 0 to 40, including all integers, rational and irrational numbers. The integers are the 1, 2, 3, -1, -2. Rationals are fractional numbers, so it could be a half a pound, 3 3/4 pounds. And irrational numbers are those that can't be expressed as a rational number, as a fractional amount. Pi is one of those numbers, e is one of those numbers, 3.14, blah, blah, blah. Okay, so the possible values of x are only the whole numbers up to and including 2. So you can do no more than 2, no more than 2, so the 2, the 1, and the 0, and only those particular values. So they've represented them by filled in dots here, so these dots are filled in. Okay. So those are the discretes, but what about the possible values of y? 0 is, maybe not, if you have 0 bags and your weights are 0 pounds. But other than that, you're going to have some weight, and it could be anything. You may have some average weight that you have in here someplace, but this whole interval, when I say interval, this filled in place between 0, 0 including, up to 40, 40 including, the numbers could come out of here. Here I couldn't pull a 1.5 for a discrete value, but here this could be 5.5, 9.9, somewhere in there, 12.32657, somewhere in there. And this is the representation of, on a number line, the interval. It's just a graphic representation. So what we would like to do is look at those in terms of inequalities, okay? So a discrete random variable is one whose possible values can be listed. So we can just, these are the only things that they can be, and that's it. Okay, in the example x, the number of bags is a discrete random variable. There's that. And then a continuous random variable is one that can take on any value in an interval. That's those things right there. That anywhere in here I can pick those, and between any numbers that I pick, no matter how close they are, there's a number in between them. So I can continuously divide some number, 2 numbers in 2, and get a number like half in here, half in here, half, 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 half. Okay, so I can't list those all out. So an event for a continuous random variable is an interval and may be represented graphically on a number line or using inequality notation. Special consideration must be given to the endpoints to determine whether they should be included as part of the event. In the example above, the words no more than 40 imply that a value of 40 is included as part of acceptable weights, whereas a statement such as less than 40 would imply that 40 is not included. So the 39.99999999999 pounds would, but the 40 not. Okay. So on a number line, a closed circle indicates that an endpoint is included. A closed circle indicates that an endpoint is included as part of the interval. And a sign that less than or equal to or greater than or equal to is what you would represent as that endpoint, the equal to. Okay, indicates that an endpoint is included, whereas a strict inequality sign, less than, greater to, implies an open circle. So for that number, that would be an open. Anything x greater than, so this would be on the other side, okay, and it would go down to that number. Okay, so that open circle indicates that an endpoint is not included. In equality notation, a non-strict inequality indicates that an endpoint is not included. This is a non-strict, this is a strict inequality, the less than or equal to. So here's a couple of examples, and then later on we're going to ask you to go through and kind of fill in the this number line with the interval that you were to say. So consider the statement, the height x is greater than 30. Represent the interval using interval notation and on a number line. Okay. So this is the inequality x greater than 30. It's not a strict, so that we're going to have the equal to. So we have an open at that, and all the numbers that are the bigger than 30, 31, 32. So that's all of these numbers in here and any number in there. As long as it's not 30 and bigger than 30, you know, we can include that and as part of this interval. So the graphical representation and the inequality. So later we're going to talk about what's the probability of x being greater than 30. So we would want that interval in there. Anything in there, any of those numbers, what would be that probability of them being in there? So here, for example 2, consider the statement the population mean is between 20 and 25 exclusive. So the exclusive is a key word there that says do not include 20 and 25. So that when you're doing a mean, like, or a number between, you're doing an interval that's between two numbers, you really need to have two words, either exclusive or inclusive. And the inclusive would include these numbers. You would fill in that down here or put the equal, and the exclusive would mean that do not include those two numbers. It's just the numbers in between them. So here's all the numbers that's in between 20 and 25. Don't include the 25. Do not include the 20, but anything else could be there. Anything bigger than 20, 20.000000001, okay, would be in there. Okay, so this is how we would write that notation, and later on, when we're dealing with probabilities, we would say what's the probability that x would be between in those two numbers between 20 and 25. This is not doing a very good job, but like that. Okay. Consider this. So the quantity n times p is at least 10. We'll kind of have to deal with these things in the future. The quantity n times p, when I'm multiplying the number in the sample times its proportion, like 30%, 40%, 0.30, 0.40, n times p is at least 10. So this is the interval that you would be dealing with. At least 10 implies 10 as well, and anything bigger than 10 would work. Okay, so in inequality notation, that's what we would do. N times p greater than or equal to 10 would be that notation in strict inequality, and this would be the graphical representation of the interval. I still got a little bit left over there. Consider the statement, whoops, went too far. Back up. Consider the statement the z-score is between -3 and 3 inclusive. There's the other version. The first we did was exclusive. The two endpoints were not included in there. These, they are. Inclusive means they're filled in and the numbers between -3 and 3. So the z-score could be anywhere in here, -2.5, -2.99, 2.99, 0.5, 0.00005, which is almost 0, and -0.000.1 would be in there. And that's how we would write that. So if I was doing probabilities again, I would say, what's the probability of the z-score landing between here and there? Okay. So here are several. Suppose that a tree is selected at random from a stand of pine trees. Represent each of the following events in inequality notations with the number line. The tree's height is at most 13.5, at most. Okay, so heights, they're going to consider the heights must be greater than 0. It's got something there. So they're just going to put this as a nice between 0 less than x, less than or equal to 13.5, because we'll consider that as the most. The tree's height is less than 20 meters. Here's the 20. We're going to do the same thing. We're going to consider the height being greater than 0, x being greater than 0, but less than 20, so it cannot be 20 meters in this, and there's the notation that we're going to be including. Open circle for 20, because we cannot include that 20. The tree's height is between 12.25 and 18.5 meters. Exclusive, so we're not going to include these things. Those are excluding the points. So we would write them without the strict equality, and here would be, we would take the open circle here at the 12.25, 18.5, we would represent that as an open circle, and this would be the inequality notation that we would use. Okay. Here is D. Let me slide back up here just a little bit. I should have said D. Here's D. The tree's height is greater than 16.6. So 16.6 would not be included. We want something greater than that. X greater than 16.6. Again, we would not include 16.6, but all the things bigger than that. And that would be the notations that we would use for the inequality. The tree's height is between 8.3 and 13.8 meters inclusive. The inclusive means these points are also included. So we would go down here and I would include the endpoints. 8.3, between 8.3 and 13.8, inclusive would be less than or equal to, it's possible that x is equal to 8.3, and here less than 13.8, but it's possible that x is 13.8. So we would represent that graphically on the number line as that interval with the endpoints included. Okay, so these little practice problems give you a chance to look at these, kind of consider this stuff, draw on these number lines what this thing represents. Okay, 20 minutes or less. Would you include 20 minutes? Yes, or less. Okay, so hope that gets you started. Submit these worksheets, and I'll see you for the next worksheet.